Chapter 13 Sound. Introduction. Close your eyes and concentrate. Listen to the different sounds around you. You will be able to identify different types of sounds. Some would be soothing, others would be harsh. Some would be loud, others would be soft. Most of the things around us, living or non-living, make sound in some way. Can you imagine how life would be if there was no sound? How is sound produced? Sound is a form of energy and it is produced when an object vibrates. All sounds are produced by vibrations. Sound of a guitar, sitar and violin are caused by the vibrations of metal strings. Sounds of tabla and drum are caused by the vibrations of the stressed membranes on them. Sound of a flute is caused by the vibrations of air column in it.
What are vibrations? Vibration is a to and fro movement of an object, just like the pendulum of a wall clock. In this type of motion, an object moves equal distance in two opposite directions. Hang a tennis ball from the wall with the help of a string and push it to one side. The ball will start moving to and fro. Observe the oscillation of the ball. What happens after some time? You will see that the ball comes to a stop in its initial position. The motion of the ball is called vibration or oscillation. Sound waves are produced by objects when they vibrate. These vibrations travel through a medium in all directions and also to our ears.
How sound propagates? When a sound is made, the air particles near the source of sound get compressed. These compressed particles transfer the energy to the neighboring particles, which make a new compression. At the same time, the first compression changes to a rarefaction. In this way, the compressions and rarefactions travel through the air. When these reach our eardrums, the eardrum vibrates. The vibrations are detected by the nerves and sent to the brain to interpret the sound. Sound travels through liquids and solids through vibrations of particles.
The above activities show you that sound can travel through all matter, solid, liquid or gas. However, the speed of sound in different mediums vary. The speed depends on how close the particles of a medium are and how fast it is transmitted. The speed of sound in air at 20 degrees Celsius is 340 minutes per second. However, it travels faster in liquids and fastest in solids. Substance, temperature, degrees Celsius, speed, meter per second. Gases, carbon dioxide, 0, 259. Oxygen, 0, 316. Air, 0, 331. Air, 20, 343. Helium, 0, 965. Liquids, chloroform, 20, 1004. Ethanol, 20, 1162. Mercury, 20, 1450. Water, 20, 1482. Solids, lead, 1960. Copper, 5010. Glass, 5640. Steel, 5960.
The speed of sound in air is much less than that of light, 3 lakh kilometers per second. During a thunderstorm, you see lightning first and hear its sound a little later. Can you now guess the reason for this? Sound cannot travel through vacuum. You have now learned that sound travels because of the vibrations of particles in a medium. If there were no particles, there would be no vibrations, and the sound will not be able to travel. For this reason, sound cannot travel through vacuum. Characteristics of sound. Sound travels through a medium in the form of compressions and rarefactions. These are collectively called sound waves. Sound waves have some characteristic properties which are as follows. Amplitude. It is the measure of intensity of sound. A large amplitude means a loud sound and small amplitude means soft sound. It is actually the measure of change in pressure in a compression or rarefaction. Wavelength. It is the distance from one compression to the next or the distance of between one rarefaction to the next. One wavelength makes one wave of sound and it constitutes one compression and one rarefaction. Frequency. It is the number of sound waves passing a point in 1 second. It is measured in a unit called Hertz, Hz, or cycles per second. For example, if 100 sound waves pass a point in 1 second, its frequency will be 100 Hz. Pitch. Pitch of a sound wave determines how it sounds to our ears. A bird chirping is a high-pitched sound, whereas a lion's roar is low-pitched sound. The higher notes on a keyboard produce a high-pitched sound, whereas lower notes produce low-pitched sound. Pitch depends on frequency. A high-pitched sound has high frequency, whereas a low-pitched sound has lower frequency. A sound with high pitch is shrill, whereas a sound with low pitch is dull. Loudness. Loudness depends on the amplitude of sound. Higher the amplitude, louder is the sound as it has more energy. Timbre. Timbre or quality of a sound wave is the property that helps us to distinguish between different sounds. How do you make out your mother's voice from your sister's? How do you differentiate between the sounds of a guitar and a keyboard? This is possible because of timbre of the sound. Different objects produce sounds of different quality. This happens because a sound made by an object is a mixture of sounds of different frequencies which we hear collectively. These frequencies may have different loudness, which helps us to identify the sounds.
How do we hear? The sound waves produced by an object travel in all directions. While traveling, these waves keep losing energy and ultimately die out. When these waves reach our ears, we are able to hear sounds. Let us learn how our ears help us to listen. Our ears have 3 parts. Outer ear. The outer ear is made up of the ear flaps and ear canal. Ear flaps or pineal are made up of skin and cartilage and are the only parts visible. The pineal collects the sound and transfers it to the ear canal. Animals like cows, dogs, and horses have bigger ear flaps, so they can hear more than us. The ear canal is a tube connected to the ear flaps. The sound travels through this canal to the eardrum. Eardrum is a stretched membrane at the end of the ear canal. It separates the outer ear from the middle ear. When the sound hits the eardrum, it vibrates. Middle ear. Middle ear consists of 3 very small bones. These are hammer, anvil, and stirrup. When the eardrum vibrates, it transfers the vibrations to hammer. Hammer transfers them to anvil, which in turn transfers it to stirrup. These bones make the vibrations larger. Inner ear. The inner ear consists of a coiled canal-like structure called cochlea. It is linked to the stirrup and is filled with fluid. It contains many hair-like cells. These cells are linked to the auditory nerves. When the stirrup vibrates, the waves move to cochlea. When the waves move through the liquid, the hair cells transmit them to the brain through the auditory nerves. The brain then interprets the sound. The cochlea is also the organ which controls our balance. When you spin for some time and then stop, you feel dizzy. This is because the liquid inside the cochlea keeps moving for some time after you stop. Taking care of ears. You should never insert any pointed object inside your ear to clean. This may damage the eardrum. The ears should be cleaned only from outside. The wax inside the ear traps the dust particles and also saves the ear from harmful microorganisms.
Can we hear all sounds? Our ears can hear sound waves of frequency range 20 to 20,000 Hz. The sound waves with frequency lower than 20 Hz are called infrasonic waves. The sound waves with frequency more than 20,000 Hz are called ultrasonic waves or ultrasound. Animals can hear ultrasonic waves of more than 20,000 Hz frequency. This is the reason they are more alert than us. Reflection of sound, echo. Reflection of sound waves from a surface creates what we know as echo. Stand in an empty room and call out your name loudly. You will hear the echo within a very short time. Echo is produced when sound waves produced by an object hit another surface and reflect back. However, for us to hear an echo separately from the original sound, there should be a time gap of 0.15 seconds. The brain cannot differentiate between two sounds if the time gap between them is less than 0.1 second. For this reason, echo is more clear when the reflecting surface is at a long distance. Applications of echo. Echo sounding has various applications in our life. One of the main uses of echo sounding is in medical industry. Another application of echo sounding is to measure the depth of water in a water body. Ultrasounds are released in water and they reflect back from the bed of the water body. From the time taken by sound to travel back and the speed of sound in water, the depth can be calculated. Absorption of sound. Wherever sound waves hit a surface, a part of them is absorbed. Talk in an empty room. Your voice will echo, but if the room is furnished, it doesn't echo. This is because the curtains, carpets, wooden cupboards, and clothes absorb sound. Such soft materials are used to cover the walls of auditoriums to stop the reflection of sound.
How do we make sound? In our throat, there is an organ called larynx. It has two vocal cords. When we speak, the air passes through the narrow slits in the vocal cords, making them vibrate. These vibrations produce sound. Vocal cords in the children are small. Due to this reason, the sound produced by the children has high frequency. Among adults, the sounds produced by women have higher frequency than the sounds produced by men. In other words, children and women produce shrill sound, whereas sound produced by men is dull.
Music and noise. If a sound is produced with irregular vibrations, it is pleasing to the ear and we call it music. This principle is used in musical instruments. Sounds of different frequency are played in a sequence, creating harmonics in the instrument. There are 7 basic notes.
These notes are played to create a musical octave.
Sa, re, ga, ma, pa, dha, ne. If sound consists of irregular vibrations, it is unpleasing to ears and is called noise. Noise pollution is the presence of excessive noise at a place. You will come across noise pollution at a busy traffic intersection, a crowded market, or a party where loud music is played. Loudness of sound is measured in a unit called decibel, dB. It ranges from just audible sounds, 1 to 10 decibel, to painfully loud sounds, 150 to 180 decibels. Noise pollution can be controlled by taking the following steps. 1. Avoid use of loudspeakers. 2. Stop unnecessary honking in traffic. 3. Installing good silencers in automobiles and industrial machines. 4. Planting trees which act as good sound absorbers.